Welcome back. In the previous video, I have discussed how to convert the given statements or facts into first order logic or the predicate logic. Link for that video is given in the description below. In this video, I will discuss how to convert the first order logic into a conjunctive normal form and how to use the resolution tree to prove the given fact. This is how the first order logic looks like for the given facts. Now, in this case, what we need to do is we need to convert this first order logic into conjunctive normal form. For that reason, the first we need to remove this implications. We need to identify where all implications are there and then we need to remove it. For removing the implication, we need to use this equation. That is, A implies B is always equivalent to negation of A or B in this case. So if you look at here, there is an implication here. So if you want to remove this implication, it will become for all x as it is, negation of food of x or likes of John comma x here. Similarly, we have one more implication here. Here there will be an negation in this case and this will be replaced with or over here. Similarly, we have to do it for all other statements. And once you do this thing, the statements will look something like this. So you can see here we have applied the eliminating implication rule for A, C. You can see here on E, F and then G here. Remaining there is no need to apply the eliminating the implication rule in this case. Now what we need to do is we need to move the negation inwards and then rewrite the statements. That is nothing but we need to apply the De Morgan's law here. In this case, we don't have any negation and the brackets over here. So there is no need to move this implication inside. If you look at here, we have one option in this case. Negation has to be moved inside. Once you move it inside, it will become negation of eats of x comma y. This will become or, and this negation will get cancelled. It will remains killed of x here. So that is how actually you can notice this C statement here. For this one, again, it is not required. For this one also, it is not required. When you come to this F statement, we need to move this negation inside. It will become negation of negation will can cancel. It will be only killed of x over here. This will be or an alive of x is as it is in this case. So in this case, we have applied this rule for two statements and then we have rewritten the statements over here or the predicates. Now we will go with the next step, that is we need to rename the variables. So whenever we have multiple number of predicates, we cannot use the same variable for all those uh, predicates here. And if you look at here, there is a x variable in the predicate A. We cannot use it in other predicates. Of course, in B we have the standard variables like apple and vegetable. There is nothing called as x, y or something like that. But when it comes to C here, we have x here and then we have x here. So what we need to do is we need to replace x with some other, we can say that the variable, or else we can do something like this. We will make this one as y and this will be z here and this will be y, and wherever y is there, we will replace it with z in this case. So that is what I have done in this particular C statement. And again, we need to apply it for E statement. This x can be replaced with some other variable. In this case, it has been replaced with w here. This one is replaced with G in this case. This X is replaced with K in this case. So this is how we can rename the variables or standardize the variables in this case. Coming back to the next one, we need to eliminate the existential quantifiers. We don't have any existential quantifiers in this case. Something like this. We don't have any existential quantifiers. So there is no need to apply this particular rule. The next step is to drop the universal quantifiers. Wherever there is a quantifiers, universal quantifiers are there, we need to remove them. So this is the first place. These are the two places, and these are the three more universal quantifiers are there. We need to remove them. There is one more thing we need to notice here. This particular B statement, food of apple and food of vegetables. The meaning of this one is this entire statement is true or valid if food of apple and food of vegetable is valid here. So rather than writing one statement, we can divide it into multiple number of statements here. So once you do it, so we have removed this universal quantifier, and here this one is written into two forms, B and C you can see here. Similarly, we have removed these two things, we have written D and so on we have done in this case. So once you drop the universal quantifiers, we will get the predicate logic in the form of conjunctive normal form here. Now, once you get the conjunctive normal form, next what we need to do is we need to draw the resolution tree to prove the given predicate here. So this is what actually we want to prove. That is, John likes peanuts in this case. In resolution tree approach, what we do is we will take the negation of this one, that is negation of John likes peanuts here, and then we will try to end up with something called as an empty set here. The meaning of this one is whatever we have assumed, that is wrong. That is John doesn't like peanuts, that is wrong. And then we will be able to prove that this particular statement is true here. So we will start with the negation of this the predicate to be proved. Now, if you want to make this one as a null state, at the end of the day, what we want the null set here. So we need to cancel it out. If you want to cancel it out, we need to identify one predicate so that we can cancel it out. So there is a negation of likes here, that is John likes peanuts. And if you look at here in this particular first predicate, we have something called as John likes X here. So we can take this one and then we can cancel this likes, because here there is a negation, here there is no negation here. So that is what I have written in this case. Now, here it's a peanuts, here it is a X. So X should be replaced with peanuts first of all. And then if you replace X with peanuts, it will become negation of John likes peanuts. John likes peanuts here. So both of them will be get cancelled. We will left with negation of food peanuts here, because X is replaced with peanuts in this case. Again, we want to cancel this food of peanuts. Food of peanuts we want to cancel. So we need to identify where we have food of peanuts here. Uh, we can see here food of Z is there. So we can use this particular food of Z. It will become the negation of this food is here, and then we have positive here. Both of them will be get cancelled. So that is what I have taken in this case. Now again, here it is Z, here it's a peanut. So wherever there is a Z is there, we need to replace Z with what? Peanuts in this case. So these two will get cancelled in that case. What is left with? This particular part will be left with over here. So as said earlier, we need to replace the Z with peanuts in this case. Now we have negation of eats y comma peanuts is there, and killed of y is there. So now we want to cancel one of these two things. So eats negation of eats y comma peanuts is here. So you can see here there is eats of anil comma peanuts in this case. So we'll take that particular thing. We need to replace this y by anil. In that case, these two things will get cancelled, and what we left with? Killed of anil in this case. So that's what is left over here. Now we want to cancel this killed of anil here. So where there is a killed is present, you can see here negation of alive k or negation of killed k is present here. So we take this one here. We will replace this k by anil in this case. So this killed of k and killed of anil will get cancelled. What is left with? Negation of alive k is left over here. K is replaced with what? Anil. So that's the reason it is negation of alive anil in this case. Now we will go with this F here. What it says? Alive anil. So that is what I have taken here. Alive anil, negation of alive anil, both will get cancelled. What is left with over here is we have left with what is that called as empty set. We have started with negation of the predicate to be proved. We ended with the empty set here. The meaning of this one is whatever we have assumed at the initial state, that is John doesn't like peanuts, is wrong. What is the actual statement here? The John likes peanuts is the true statements, or you can say that the valid statement in this case. So this is how we can use the resolution tree to prove the given statement valid or invalid in this case. So in this video, I have discussed how can we convert the first order logic into the conjunctive normal form, as well as how to prove the given statement or the predicate using the resolution tree. I hope the concept is clear. If you like the video, do like and share with your friends. Press the subscribe button for more videos. Press the bell icon for regular updates. Thank you for watching.